Good day, everyone. For Mathematics Quarter 1, Week 1 module, we will be having 3 lessons. These lessons are the first 3 special factors. Starting off with factoring using GCMF. Second, factoring difference of two squares. And third, factoring sum and difference of two cubes. At the end of the lesson, you're expected to factor completely different types of polynomials. Polynomials with common monomial factor, difference of two squares, and sum and difference of two cubes. Let's start with factoring using GCMF. GCMF stands for Greatest Common Monomial Factor. For the what's in part of the module, you need to answer the pieces of my life and the what's new part. You answer the problem there. We have here similar activity. We have a rectangle with length x minus 5 and width 3. Let's find for the area of the rectangle using the formula length times width. By substitution, we have x minus 5 times 3. So to find for the area, we need to multiply x minus 5 by 3 using distributive property. So we will distribute 3 to all the terms inside the parentheses. So we have 3 times x, that is 3x, and 3 times negative 5, that's negative 15. So the area of the rectangle is 3x minus 15. What's it part? Taking the area of the rectangle, which is 3x minus 15, let's go back. 3x was taken from the product of 3 and x. And 15 is from 3 times 5. As you can see, 3x and 15 they have a common factor, that is 3. Taking out 3, we have now the remaining factor, x minus 5. So from the product, which is 3x minus 15, we arrive at the factors 3 times x minus 5 by taking out the special or the common factor. That is the process of factoring. Let's have an example in factoring using GCMF. Find the GCF of 4x cubed and 8x squared. First step, factor each monomial. So we have two monomials, 4x cubed and 8x squared. In factoring the monomial, you start from the numerical coefficient, 4. Factors of 4, we have 2 times 2. For x cubed means we're going to multiply x 3 times by itself, or that is the same as multiplying 3x's. And then for 8, using prime factorization, we have 4 times 2, and then under 4, because 4 is already a composite, is still a composite number, so it has factors 2 times 2. So we have 2 times 2 times 2. And then x squared is the same as x times x. Second step, identify the common factors. Now, looking at the factors of 4x cubed and 8x squared, we can easily see the common factors. We have the common factors, 2, this one, x, and then another x. Third and last step, find the product of the common factors. Let's take the common factors. We have 2 times 2 times x times x. Taking the product of 2 times 2 times x, we have 2 times 2, that is 4, and then x times x is x squared. So this 4x squared, which is the product, is the GCF of 4x cubed and 8x squared. Next example. Find the GCF of 15y raised to 6 and 9z. Again, let's factor each monomial. 15y raised to 6 and 9z. For 15y raised to 6, 15 has factors 3 and 5. And y raised to 6 is the same as multiplying y 6 times by itself. So we have 6y's. And then for 9z, factors of 9 are 3 and 3. And then we have z. Next, identify the common factors. We only have one, and that is 3. Find the product of the common factors. Since we only have one common factor, so we don't have to take the product. So 3 now is the GCF of 15y raised to 6 and 9z. Now, have you mastered finding the GCF of given monomials? You need to master this one because you'll need this in factoring using the greatest common monomial factor. Example 2. Write 6x plus 3x squared in factored form. Step 1. Determine the number of terms. If you can still remember, term is a constant, a variable, or a combination of a constant and a variable. Since the given is a binomial, you can easily determine the term because they are separated by the plus or the minus sign. So we have here the plus sign. So the terms are 6x and 3x squared. So we have 1, 2. We have 2 terms. Determine the GCF of the numerical coefficients. That numerical coefficient is the terms number part. So for 6x, the numerical coefficient is 6. And for 3x squared, we have 3. Factors of 6 are 3 and 2. And factors of 3, we have 3 and 1, or simply 3. Get the common factor, we have 3. Next, determine the GCF of the variables. The variables are x and x squared. For x, we have x. And for x squared, we have x times x. So the common factor is x. Next, find the product of the GCF of the numerical coefficients and variables. The GCF of the numerical coefficients is 3, and the GCF of the variables is x. So if we take the product of 3 and x, the answer is 3x. This 3x now is our GCMF, or the greatest common monomial factor of the given polynomial. Next step. Find the other factor by dividing each term of the polynomial by the GCMF. we have the given 6x plus 3x squared. So we need to divide each term, we have these two terms, by the GCMF. Our GCMF is 3x. So we have 3x divided by 3x. So we have 6 divided by 3, that is 2. And then x divided by x is 1. Or you can cancel x. Bring down plus. 3 divided by 3 is 1. Or cancel. X squared divided by x is x. So we have 2 plus x. This is now the remaining factor. Last step. Write the complete factored form. In writing the complete factored form, consider the GCMF and the remaining factor. So the complete factored form is in the form GCMF times the remaining factor. Our GCMF is 3x and the remaining factor is 2 plus x. So we have 3x times 2 plus x. Therefore, 6x plus 3x squared when factored is equal to 3x times 2 plus x. Next example. Write 12x cubed y raised to 5 minus 20x raised to 5 y squared z in factored form. Step 1. Determine the number of terms. So we have 12x cubed y raised to 5 and 20x raised to 5 y squared z. Don't forget that terms are separated by plus or minus sign. So we have 1, 2. We have 2 terms. Determine the GCF of the numerical coefficients. The numerical coefficient of the first term is 12. And the numerical coefficient of the second term is 20. Aside from prime factorization, you can also make a list of the factors of the given numbers, like this. So starting from 1 up to the given number. What numbers are exactly divisible by 12? So we have 1, 2, 3, 4, 6, and 12. For 20, you can divide it exactly by 1, 2, 4, 5, 10, and 20. Now for GCF, it's greatest common factor. So we need to simply look at the greatest common factor of the listed factors of the two numbers. So we have 4. Therefore, the GCF is 4. Step 3. Determine the GCF of the variables. We have x cubed y raised to 5 and x raised to 5 y squared z. Now, to easily get the GCF of the given variables, of the given terms, simply copy the letter or the variable common to both terms. So we have x, because both terms has the variable x. Now, for each exponent, just take the lower exponent. On the first term, we have x cubed. Second term, we have x raised to 5. Okay, so we will take 3. Because 3 is less than 5. And then, we also have another common variable, which is y. Y has the exponents 5 and 2. We'll take the lesser exponent, so we have 2. And then we have z, but there is no z variable on the first term. So we only have x cubed y squared. This is now the GCF of the variables. Step 4. Find the product of the GCF of the numerical coefficients and variables. GCF of the numerical coefficient is 4, and GCF of the variables is x cubed y squared. Multiplying the two GCFs, we have 4x cubed y squared. This is now the GCMF. Step 5. Find the other factor by dividing each term of the polynomial by the GCF. The given is 12x cubed y raised to 5 minus 20x raised to 5 y squared z. We will divide the two terms by the GCMF, which is 4x cubed y squared. Dividing it, we have 12 divided by 4 is 3. Cancel x cubed. And for y, we have y raised to 3. If you can still remember the laws of exponents, the quotient of a power, common base, different exponent, the operation is division. You simply have to copy the common base and then subtract the exponents. So we have y, and then 5 minus 2 is 3. Copy the operation, and then 20 divided by 4 is 5. X raised to 5 divided by x raised to 3, that is x raised to 5 minus 3, which is 2. Cancel y squared and then bring down z. So this is now the remaining factor. Next, last step. Write the complete factored form. So we have 4x cubed y squared, which is the GCMF, times the 3y cubed minus 5x squared z, which is the remaining factor. Don't forget the factored form, GCMF times the remaining factor. Therefore, the complete factored form of 12x cubed y raised to 5 minus 20x raised to 5 y squared z is 4x cubed y squared times 3y cubed minus 5x squared z. Example 4. Write 12x cubed minus 18xy plus 24x in factored form. First step, determine the number of terms. So in this example, we have the terms 12x cubed, 18xy, and 24x. So we have 3 terms. Next, determine the GCF of the numerical coefficients. We have 3 terms. The numerical coefficient of these terms are 12, 18, and 24. Factors of 12 are 1, 2, 3, 4, 6, and 12. 18, 1, 2, 3, 6, 9, 18. 24, 1, 2, 3, 4, 6, 8, 12, and 24. The highest common factor or the greatest common factor is 6. So 6 is the GCF of the numerical coefficients of the given polynomial. Step 3. Determine the GCF of the variables. The variables are x cubed, xy, and x. As you can see, they only have one common variable, and that is x. And the lowest exponent of x is 1, or simply x. X raised to 1, or simply x. So this is the GCF of the variables. Next, step 4. Find the product of the GCF of the numerical coefficients and variables. The GCF of the numerical coefficient is 6, and the GCF of the variable is x. So we have 6 times x, and that is 6x. This is now the GCF. Find the other factor by dividing each term of the polynomial by the GCMF. Given 12x cubed minus 18xy plus 24x. We will divide each term by the GCMF, which is 6x. 12x cubed divided by 6x, that is 12 divided by 6, we have 2. X cubed divided by x, that is x raised to 3 minus 1. So we have x squared. Bring down minus. 18 divided by 6 is 3. Cancel x and bring down y. Plus, 24 divided by 6 is 4. Then cancel x. So this is the remaining factor. Step 6. Write the complete factored form. So we have the GCMF times the remaining factor 2x squared minus 3y plus 4. Therefore, the complete factored form of 12x cubed minus 18xy plus 24x is 6x times 2x squared minus 3y plus 4. Fifth example. Write 28x cubed z squared plus 14x squared y cubed plus 36yz raised to 4 in factored form. Determine the number of terms. We have 1, 2, and 3. So we have 3 terms. Next, determine the GCF of the numerical coefficients. The numerical coefficients of the 3 terms are 28, 14, and 36. The factors of 28 are 1, 2, 4, 7, 14, and 28. For 14, we have 1, 2, 7, and 14. For 36, you can divide it exactly by 1, 2, 3, 4, 6, 9, 12, 18, and 36. Based on the listed factors, the greatest is 2. So the GCF of the numerical coefficients is 2. Next step. Determine the GCF of the variables. Okay, let us observe the letters. For letter X, it is in the first and second terms, but it's not found on the third term. For Y, it's on the second and last term, but it's not on the first term. For Z, it's not in the first term, it's in the first term and last term, but not in the middle term. So we cannot see a letter which is common to the 3 terms. Therefore, the GCF is 1. Next, find the product of the GCF of the numerical coefficients and variables. The GCF of the numerical coefficients is 2. For the variables, it's 1. So 2 times 1, that's 2. So 2 is the GCMF. Step 5. Find the other factor by dividing each term of the polynomial by the GCMF. So from the given, we have 28x cubed z squared plus 14x squared y cubed plus 36yz raised to 4. We will divide each term by the GCMF, which is 2. So we have 28 divided by 2 is 14. Now, since there is no variable in the divisor, we will bring down the variables of the dividend. So bring down x cubed z squared, and then plus 14 divided by 2 is 7. Bring down x squared y cubed plus 36 divided by 2 is 18, then yz raised to 4. So this is the remaining factor. Last step, write the complete factored form. We have the GCM x cubed z squared plus 7x squared y cubed plus 18yz raised to 4. Therefore, the complete factored form of the given polynomial is 2 times 14x cubed z squared plus 7x squared y cubed plus 18yz raised to 4. To summarize, there are 6 steps in factoring using GCMF. First, determine the number of terms. Step 2, find the GCF of the numerical coefficients. Step 3, find the GCF of the variables. Step 4, find the GCMF by getting the product of the GCF of the numerical coefficients and variables. Step 5, find the remaining factor by dividing the given polynomial by the GCMF. And last step, write the final factored form of the polynomial using the form GCMF times the remaining factor. For the what's more part, you have to determine the GCMF and the factored form of each polynomial. For the part B, you need to complete the factoring of the given polynomials using GCMF. For the what I have learned part, complete the given statements. Lesson 2, we have factoring difference of two squares. For the what's in part of the module, you have to determine which of the given numbers is or are perfect squares. When we say perfect squares, these are numbers that can be expressed as the product of two equal or two the same integers. Say for example, 9, because it has two common factors, 3 and 3. 25. 25 has factors 5 and 5. For the what's new part, determine the product of each sum and difference of two terms. You will apply here our past lesson on special products, the sum and difference of two terms. If we have the factors a plus b and a minus b, we have the product a squared minus b squared that is based on the sum and difference of two terms. The a squared here in the product is taken by squaring the first term, while the b squared is taken by squaring the second term. of the given binomial. For difference of two squares, from the product a squared minus b squared to the factors a plus b times a minus b. You can say that it's a difference of two squares if the first term of the binomial is a perfect square and the second term of the binomial is also a perfect square and the operation is minus or subtraction. So if you have a difference of two squares, the factors are two binomials, which is a sum and difference of two terms. So it always has a plus and a minus sign. The signs can be interchanged. And then the first terms, these are the square root of the first term. So they are the same. Square root of the first term of the given difference of two squares. And of course, the second term is the square root of the second term of the given difference of two squares. Examples of perfect squares. For 16, we have 16 because it has factors 4 and 4. Or it can be written as the square of 4. We also have x squared. In expanded form, it's x times x. Or it can be written as the square of x. We also have 25a squared. Factors of 25, 5 and 5. And then for a squared, we have a and a. So 25a squared can be expanded to 5a times 5a. Or the square of 5a. We also have 9y raised to 4. That is 3y squared times 3y squared, or the square of 3y squared. 1/4. Square root of 1/4 is 1/2. So 1/4 is equal to 1/2 times 1/2, or the square of 1/2. Let's have examples on the difference of two squares. First example. Write x squared minus 9 in completely factored form. Step 1. Express the first and the second terms in exponential form with a power of 2. So we have x squared, that is x times x, or the square of x. For 9, we have 3 times 3, or the square of 3. Second step, subtract the two terms in exponential form following the pattern a squared minus b squared. So we have a squared, that's x squared, and then for b squared, that is 3 squared. Factor completely following the pattern a squared minus b squared is equal to a plus b times a minus b. From step 2, we have x squared minus 3 squared. So the factors are, we have the first term x, and then plus and minus, and then the second term is 3. So the complete factored form x squared minus 9 is x plus 3 times x minus 3. Second example. Write 16a raised to 6 minus 25b squared in completely factored Step 1. Express the terms in exponential 2. So we have 16a raised to 6. Square root of 16 is 4. To easily get the square root of the variable, you simply have to divide the exponent by 2. So 6 divided by 2 is 3. So we have a cubed. Or the square of 4a cubed. Next, 25b squared. That is 5b times 5b, or the square of 5b. Step 2. Subtract the two terms in exponential form following the pattern a squared minus b squared. So this is a squared minus b squared from step 1. So we have the square of 4a cubed and minus the square of 5b. Factor completely following the pattern a squared minus b squared is equal to a plus b times a minus b. So from the square of 4a cubed minus the square of 5b, we will take the two binomial factors. The first term is 4a cubed, the plus and the minus sign, and the second term is 5b. So the completely factored form of 16a raised to 6 minus 25b squared is 4a cubed plus 5b times 4a cubed minus 5b. Example 3. Write a squared b raised to 4 minus 81 in completely factored form. First step again. Express the first and the second terms in exponential form with the power of 2. For a squared b raised to 4, we have ab squared times b squared or the square of ab squared. We have 81, that's 9 times 9, or the square of 9. Step 2. In the form a squared minus b squared, we have now the square of ab squared minus the square of 9. So from step 2, we will derive the two binomial factors. The first term is ab squared. So ab squared, then plus and minus 9, which is the second term. So the completely factored form of a squared b raised to 4 minus 81 is ab squared plus 9 times ab squared minus 9. To summarize the steps in factoring difference of two squares, we have 3. Step 1. Express the first and the second terms in exponential form with a power of 2. Step 2. Subtract the two terms in exponential form following the pattern a squared minus b squared. And step 3. Factor completely following the pattern a squared minus b squared is equal to a plus b times a minus b. Example 4. Write x raised to 4 minus 81 in completely factored form. Step 1. Express the first and second terms in exponential form with the power of 2. So we have x raised to 4. That's x squared times x squared, or the square of x squared. For 81, we have 9 times 9, or the square of 9. Step 2. Subtract the two terms in exponential form following the pattern a squared minus b squared. So we have square of x squared minus the square of 9. Step 3. Factor completely following the pattern a squared minus b squared is equal to a plus b times a minus b. So from step 2, we have the square of x squared minus the square of 9. We will take the two binomial factors with the first term x squared, and then don't forget the plus and minus sign, and then the second term 9. But observe x squared minus 9. X squared is a perfect square and 9 is a perfect square. And the operation is using the two squares. Factoring x squared minus 9, we have x plus 3 times x minus 3. So the complete factored form of x raised to 4 minus 81 is x squared plus 9, and then the factors of x squared minus 9, x plus 3 times x minus 3. So the completely factored form is x squared plus 9 times x plus 3 times x minus 3. Last example. Write 3w squared minus 48 in completely factored form. If you observe the given binomial, 3w squared, the numerical coefficient alone, 3, is not a perfect square. Also with 48, it's not a perfect square. So what should we do? Always remember that there are more than one factoring techniques. And we had the first one, which is factoring using GCMF. And if you'll observe 3w squared and 48, they have a common factor, which is 3. So factoring out the common factor, which is 3, the remaining factors are w squared minus 16. So from 3 times w squared minus 16, we will take w squared minus 16 because this is a difference of two squares. So we will now write w squared minus 16 in completely factored form. So that's the square of w minus the square of 4. So step 3, factor completely. And the square of w minus the square of 4. So the two binomial factors are w plus 4 and w times w minus 4. And so for the completely factored form of w squared minus 16, we have the GCMF a while back, which is 3 times the factored form of w squared minus 16, which is w plus 4 times w minus 4. So this is now the completely factored form of 3w squared minus 48. For the what's more part, you need to answer the 4 parts there. A, tell whether or not the given binomial is the difference of two squares. B, complete the factoring. C, choose the factors that correspond to each polynomial. And D, you need to complete the factoring again. Next, for the what I have learned part, you just have to answer the two questions there. Let's now proceed on to lesson number 3. Factoring sum and difference of two cubes. For the what's in part, express the given expressions in exponential form with a power of 3. What's new? See the pattern on the given examples. And Now, let's have factoring sum and difference of two cubes. It is in the form a cube plus or minus b cube. That is the sum and difference of two cubes. And if you factor that, the factors are a binomial and a trinomial. For the binomial, it's in the form a plus or minus b. And for the trinomial, it's a squared plus or minus ab plus b squared. In order for you to determine if it's a sum and difference of two cubes, we need to consider the following. It must be a binomial with the first term, which is a perfect cube. And the second term is also a perfect cube. The operation is either plus or minus. Now, if it's a sum and difference of two cubes, the factors are a binomial and a trinomial. To get for the binomial factor, the first term of the binomial factor is taken by getting the cube root of the first term. First term of the given binomial. So we have here a cube. So a is taken by getting the cube root of a cube. And then for the second term of the binomial factor, it is taken by getting the cube root of the second term of the given binomial. For the operation, it must be of the same sign with the given. So if the given binomial is plus, this must also be plus. Minus then. And then for the trinomial factor, the basis for the trinomial factor is not the given anymore. It must be the binomial factor. The sign of the middle term of the trinomial should be the opposite of the operation of the given. So if the given is plus, this must be minus. If the given is minus, this must be plus. For the operation of the last operation, it must always be plus. For the first term of the trinomial, it is taken by squaring the first term of the binomial factor. So for the binomial factor, we have a, first term is a, so the first term of the trinomial factor is taken by squaring a. For the third term, it is taken by squaring the second term of the binomial factor. And the middle term is taken by getting the product of the first and second term of the binomial factor. I repeat, that the trinomial factor of the sum and difference of two cubes your basis should be the binomial factor. Let's have example. Factor y cubed minus 27. Y cubed minus 27, we have a binomial and trinomial factor. The first term of the binomial factor is taken by getting the cube root of y. What is the cube root of y? For variables, if you're taking the cube root of variables, you just have to divide the exponent by 3. So we have y, and then the exponent is 3 divided by 3, which is 1, y raised to 1, or simply y. Next, cube root of 27. We all know that 27, when expressed in a power of 3, that is 3 cubed. Therefore, the cube root of 27 is 3. For the operation of the binomial, simply copy the operation of the given. And then if that is minus, this is plus, and this is always plus. For the first term of the trinomial factor, we will square y. Squaring y, that is y squared. And then for the last term, that is taken by squaring the second term of the binomial factor, which is 3. So we have 3 squared, and that is 9. For the middle term, that is taken by multiplying the first and second term of the binomial factor. So we have y times 3 or 3 times y, that is 3y. So the factor of y cubed minus 27 is y minus 3 times y squared plus 3y plus 9. Example 2. Factor 8x cubed minus 64. We have 8x cubed minus 64. Take note, before proceeding to factoring sum and difference of two cubes, you need to determine if there is a common factor on the given terms of the binomial. Like this one, 8x cubed and 64. There is a common factor which is 8. Factoring using GCMF. Taking out the GCMF, which is 8, we have 8x cubed divided by 8, that is x cubed, minus 64 divided by 8 is 8. Now this x cubed minus 8 is a difference of 2 cubes. Therefore, factoring x cubed minus 8, we have the binomial factor with the first term taken by dividing x cubed or getting the cube root of x cubed. So we have x. And then cube root of 8 is 2. Same operation. If that is minus, the middle term is plus. And the last sign is plus. For the first term, we square x. So that's x squared. For the last term, we have to square 2, so that's 4. And for the middle term, we will multiply x times 2, so that's 2x. So the completely factored form of 8x cubed minus 64 is 8 times x minus 2 times x squared plus 2x plus 4. Example 3. Factor 27m raised to 4 minus 8mn raised to 6. Again, observe that there is a common factor again, and that is m. Factoring out m, we have 27m cubed minus 8n raised to 6, which is the remaining factor. Now, the remaining factor is a difference of 2 cubes. Therefore, when factored, we have a binomial and a trinomial. For the first term of the binomial factor, that is cube root of 27 is 3, and cube root of m cubed is m. For the second term, cube root of 8 is 2, and then we have n raised to 6 divided by 2 is 6 divided by 3 is 2. Then copy minus. If that is minus, this is plus, plus. For the first term of the trinomial factor, we have the square of the first term of the binomial factor, 3m. 3m squared, that is 3 times 3 is 9, m times m is m squared. Next, square of 2n. Square of 2n, that is 2 times 2, 4. And then the square of n squared is n raised to 4. For the middle term, we have 3 times 2, that is 6. And then m times n squared, mn squared. So the complete factor of 27m raised to 4 minus 8mn raised to 6 is m times 3m minus 2n squared times 9m squared plus 6mn squared plus 4n raised to 4. For example, factor 1 plus 8k cubed. This time it's a sum of 2 cubes. So again, we have a binomial and trinomial factor. The first term of the binomial factor is simply the cube root of 1, and that is 1. Cube root of 8k cubed, cube root of 8 is 2, and cube root of k cubed is k. So we have 2k. Copy the sign, we have plus. And then, if that is plus, this should be minus, and the last term should be plus. 1 squared. For the first term of the trinomial factor, we have to square 1, so we have 1. For the last term, we have to square 2k, so we have 4k squared. And then for the middle term, 1 times 2k is 2k. So the complete factor of 1 plus 8k cubed is 1 plus 2k times 1 minus 2k plus 4k squared. Last example. Factor 5h plus 40hk cubed. Again, it has last example. Factor 5h plus 40hk cubed. We have 5h plus 40hk cubed. Note that it has a common factor, which is 5h. Factoring out 5h, we have 1 plus 8k cubed by dividing the given binomial by 5h. Next, since 1 plus 8k cubed is a sum of 2 cubes, we will factor it and then cube root of 8k cubed is 2k. It's plus, so we have plus. For the trinomial factor, since the given is plus, this should be minus and then plus. Square of 1 is 1, square of 2k is 4k squared, and 1 times 2k is 2k. So the complete factor of 5h plus 40hk cubed using GCMF and sum of 2 cubes is 5h times 1 plus 2k times 1 minus 2k plus 4k squared. That ends the discussion for factoring sum and difference of 2 cubes. Now for the what's more part, you need to answer the activity titled cube to the left, cube to the right. And then for part 2, complete the factoring. Part 3, factor the given polynomials. For what I have learned, again, you have to answer the given questions. For what I can do, you need to solve the given problem. After that, you need to answer the 15-item post-assessment. And of course, don't forget to answer the additional activities student. Good luck!